Sometimes UART can output such garbage values. So there are 4 things you can try to rectify such issue. We can start with verifying our baud rate settings. So let's close the terminal and we will open the terminal again to verify the baud rate. So I'm using the baud rate 9600. We need to make sure that in Design Studio our baud rate setting is same as what is set on the terminal. Let's go to peripherals and UART driver. As you can see, I'm using UART channel number 1, and in the baud rate my settings are correct, is 9600. So it seems like there's no problem with the baud rate. Let's go back to the code. You can also verify the baud rate that is automatically generated by Design Studio. Click on your configuration, and as you can see over here, the actual baud rate is 9603. It's okay. As long as it's under 20% of the tolerance, your baud rate is okay. So there's no problem with the baud rate. Let's go and verify the PLL frequency. Since I'm using an external oscillator, I need to make sure that oscillator frequency matches with the clock settings. So let's go back and see my UART channel number 1 here uses a slow clock source. And the slow clock source is right now getting its frequency from the PLL. And down, if you go, you see the PLL phase 0 is at 160 megahertz, is driven by an external clock source of 24 megahertz. That is wrong. I am using 16 megahertz external oscillator. So I have corrected my clock source and the frequency value. I will change my prescaler so I can get 160 megahertz frequency for the MCU core. Let's save it, update the code, and run again. Let's build the project and debug as Flash. In my case, I'm using Flash debug. Let's reset our terminal so we can get a new code running and outputting the new data. Okay, the build is done. Let's run. And as you can see, in my case, the PLL frequency was wrong, so my UART is now working correctly. One thing you need to make sure when you're using external oscillator is that you have called this function, distribute PLL. If you don't call this function, your clock may not work correctly. Okay, let's go back and let's try a third option. In case none of the 2 options work, you can reduce the MCU core clock and go to the clock source, and you can see as I'm using 160 megahertz MCU core clock, we can change the prescaler to reduce it. But I would like to set it to divide by 4, would be better, the whole number. 80 megahertz. Now I have set my core clock to 80 megahertz, and we can now just see that the core clocks have changed here, and we can update the code and test with the reduced core clock. Okay, I'll build the project again, and debug has okay, let's reset our terminal. Okay, the build is done. Let's step through and run. Okay, it seems like by reducing the core clock, my UART is still working. In some cases, for some people, the reducing core clock may not also work. So you can try with the internal clock source. Let's go back to the clock settings, and here on top you can see there is a mux. You can double click on it and change it to fast internal RC oscillator, which is outputting at 48 megahertz. Well, you can see the clock has reduced over here, so you can actually change the prescaler sometime to increase it. But since I increased it, you can see now I have an error on top. And the error saying that the slow clock and the HSC clock module must have a ratio of 1/2 or 1/4. but I have set a prescaler for both of them divide by 2. I have to change it, so let's change it to divide by 4. Okay, it's okay, seems to be okay. I have set the prescaler divide by 4 and it's all okay. Let's save the settings and update the code. Let's go back to the code, build, and test, this time with an internal clock source. Okay, it's loading the application. Okay, let's step through quickly and run. And as you can see, it's my UART is also working with internal clock source. You should try all of the 4 options. If none of those work, it is possible that you have some issue with your hardware.